Now we're still in exercise 5F. We're up to question 2C. So we've done parts A and B, and question 2C said to differentiate both sides of this identity. Now, the left-hand side is easy to differentiate, but the right-hand side, what I like to do, I like to expand it first because if I just write out what the right-hand side is, it's the sum of all terms from k equals 0 to k equals n. So the first term would be nc0, x to the 0 is 1. The second term would be nc1, x to the 1, or nc1x. The second term would be nc2, x squared. Plus, I'm not going to put all the terms in. I'm going to put the last term would be ncn, x to the n. So it's asking me to differentiate both sides of this identity. The reason I'm keeping the left-hand side the same, but I'm expanding the right-hand side to show that the first term is nc0, because the first term is k is 0, x to the 0 is 1, so it's just nc0. Second term, what it is. Third term, up to the last term, because it's from k is 0 to k is n. The reason I'm doing this is that when you differentiate, you're not going to start at k is 0. You'll see what you'll start with in a minute, okay? So I've just written out what they want us to differentiate, and I've expanded the right-hand side with some dots in the middle just to show what that expression is. Now I'm differentiating both sides. So differentiating both sides, I get what? What do I do with... So differentiating both sides, what do I get? What do I do with this power of n? Bring it down. N, bracket. 1 plus x to the n what? Minus 1 is. What will happen with the nc0? It goes. And what do you end up with? Differentiate a constant, you get 0. Differentiate nc1x, you just get nc1. Differentiate nc2 times 2x, you get nc2. Sorry. If you differentiate nc2x squared, you get nc2 times 2x. Plus, actually I might put the third term in. Alright, I think I need another one. If you differentiate nc3x cubed, you get nc3. Anyone? I've thrown an extra term in. Plus, if you differentiate the last one, which is ncn x to the n, you get ncn. If you differentiate that, what do you get? nx to the n minus 1. So, are we okay there? We're off the edge of the paper. So, I'm just going to... So if you look at what you're trying to prove, you're trying to show... So we've differentiated both sides, okay? Part 2 says, by substituting x is 1, you have to show... I'm writing the question out now, that from k equals 1 to n, k to the n, c to the k equals n, 2 to the n minus 1. So it says, that looks a bit weird, but we'll see what we get. I wonder if that's meant to be an x. Whatever, it could be a k, that's fine. It says, by substituting x is 1 into that thing that I've just differentiated, show this result. Well, let's substitute x is 1. What do we get? What do you get? N, bracket, substitute x is 1 here. What do I get? 2, yeah, 1 plus 1 to the n minus 1 equals nc1 plus. Substituting x is 1, what do I get? If I put x, yeah, plus 2 nc2 plus, substituting n is 1, what do I get? 3 nc3 plus, keep going, plus, substitute x is 1. When I get 1 to the n minus 1, that's 1 to the power of some positive number, is just going to be 1. Because n is just a positive coefficient, like positive integer. So I'll get 1 to the, doesn't matter what it is, 1 to the 50, 1 to the 30, it doesn't matter. I'll get n, ncn. So therefore, what I've got is, because 1 to the anything is 1. So therefore n times 2 to the power of n minus 1 is equal to, now look at the general term. The general term, the number at the front seems to be the same as this little subscript here. So isn't this 1 NC1 plus 2 NC2 plus 3 NC3 plus all the way up to n NCN? So that to me looks like general format is, you know how you've normally got NCK? Well, this little k is the same as the number at the front. K NCK, but wait a sec, don't write it yet. So it's the sum of all k NCKs. And what does your k start from with your first one? What's it start from? What's your first k value? From k is 1, and look here, all the way up to k is n. Now, notice with the original question, this is why I expanded, because with the original question, you were going from k is 0 up to n for that expression, and then you differentiated it. When you differentiate NC0, you lose it. So therefore, it won't be the sum from k is 0 to n anymore. It'll be the sum from k is 1 to n of k NCK, CNK. Wrong way. NCK, thank you. See how that's k, the number up there is the same as this little one, k, n, c, k. Got it? Sorry, girls. So the trick here is when it's in this format, I would expand it first, then I'd differentiate it, and then I'd put it back into that format so that you get the first and the last terms correct, which k value it happens to be. Then part 3 says by substituting x equals -1 into that expression, we want to show that the sum of all terms from k is 1 to n is of -1 to the k minus 1 times k to the n times k times nck equals 0. So we have to show that the sum of all terms from k is 1 to n of -1 to the power of k minus 1 times k, this is obviously an nck, so that all equals 0. So we're substituting x is -1 into the differentiated expression. So we're substituting it into this. You okay? And we're going to try and get that. So let's substitute x is -1 into here. What do we get? N times. So what you do, you start with your expression, you differentiate it, and then you'll substitute something into it. So n times 1 minus 1 to the n minus 1 equals nc1. Now, plus nc2 times 2 times -1 is what? Minus 2 nc2. Plus nc3 times 3 times -1 squared is going to be a minus or a plus? Plus 3 times nc3. Obviously, the next one's minus. It looks like the odds are pluses and the evens will be minuses. I'm just going to go minus, whatever. I'm just going to go plus all the way up to, what's the last one? Isn't it just going to be NC N -1? Why have I got, no. NCN N times -1. NCN N times -1 to the N minus 1. Because it's NCN N times X to the N minus 1, and I'm substituting X is -1. So if I look at my left-hand side, sorry, I've got, that's an N by the way, N times what? What's 1 minus 1? So I've got 0 equals NC1 minus 2 times, minus a big 2, sorry, minus 2 times, oops, keep doing the wrong thing, minus 2 times NC2 plus a big 3 times NC3 plus etc. NCN times, oh, I'm going to put the N in the front. You know how it was NCN times N? All these others have numbers at the front, so I'm going to go N times NCN, negative 1 to the N minus 1. So I'm just putting that N in front because those are in front of all the others, like the 2 and the 3, etc. Now, but the thing is, what we're going to have to do here is we need to rewrite this as a summation. So this is the sum. I'm just going to put the general term here, but notice you've got 1 NC1 minus 2 NC2 plus 3 NC3, whatever. I don't know whether this last one, it depends on N, whether it's odd or even, as to whether you'd get this is a plus or a minus term at the end. So let's say N was 18 or something. You'd get negative 1 to the 17, it would be negative. If N was 17, you'd get 17 minus 1, you'd have an even power here, that last term would be positive. It just depends on what the value of N is, and it doesn't matter, all right? But we've got the sum starting from K is what? What are you starting from? We've got to try and, K is 1, do you see? K is 1 up to N. Now, you've got K, you know how you've got, see how you've got NC2 times this? You've got NCK. Do you see what I'm doing? I've got definitely this is NCK. That K is the same as this, but it depends. Sometimes this K will be positive in front of it, sometimes it's negative. So that's where you put negative 1 to the power of K minus 1. You know what you can do? You just take the last term. See the last term here? And you just replace the N anywhere along. You've got NCK. You've got K, NCK, negative 1 to the K minus 1. Because, oh, I think it's N minus 1. No. It just depends on, because it depends. Just watch. When K is 1, what do you get here? When K is 1, I have to get the first term. Watch. When K is 1, I get negative 1 to the 0 is 1. Positive. So when K is 1, I get 1 times NC1. When K is 2, what do I get here? 2 minus 1 is 1. Negative 1 to the 1 gives me the negative. I get negative 2 NC2. Do you see why it's K minus 1? When K is 3, I get an even power. I get negative 1 squared. Makes it positive. And I get 3 NC3. Do you see why it's K? Okay? Because that K there does the positive, positive, negative, positive in front. Okay? It tells you whether the term is positive or negative. Okay? That's the end of question C, part 3, by substituting x is negative 1. All right? Now, for part D, it says to integrate the function again. So, question 2D, it says to integrate both sides of the identity. So, we've got 1 plus x to the power of n equals sum from k to 0 to n of n c k x to the k. It asks us to integrate both sides of that identity to prove a certain result. Before you integrate both sides of the identity, you can expand it first. Look, once you get used to seeing what the result's going to be, you may not expand it, but at the moment we need to. So 1 plus x to the power of n, how do I write that out? Don't I start with k is 0? So isn't it nc0 plus x to the 0 is just 1? Plus what's the second term? nc1. Start from k is 0, then k is 1, what do you get? nc1 what? They've given us this identity. Sometimes they give it as a summation notation like this, and we have to expand it first. So when k is 0, this is sum of all terms from k is 0 to n. When k is 0, we get nc0, x to the 0 is 1. When k is 1, we get nc1, x to the 1. When k is 2, we get nc2, x squared, plus nc3, x cubed, plus all the way up to ncn, because it's saying from k is 0 to k is n, ncn, x to the n. Now it says to integrate both sides. So integrating both sides, we get, they've got the k on the left, so we're going to stick the k on the left, all right? So what do we get? 1 plus x to the n plus 1 over n plus 1 times coefficient of the x is 1. Because you're integrating ax plus b to the power of n, you get ax plus b to the n plus 1 over n plus 1 times the coefficient of x. Don't forget the plus k equals. Integrate the right-hand side, what do you get? Do we know? nc0 x plus nc1 x squared on 2 plus nc2 x cubed on 3 plus nc3 x to the 4 on 4 plus all the way up to ncn x to the n plus 1 over n plus 1. So we've integrated both sides of the identity. We still haven't shown that result that they want because we have to condense this back down to summation notation. So that happens to be 1 over n plus 1, just writing it the way that they want, 1 plus x to the n plus 1 plus k equals. Doing it with summation notation, it's easy to look at the last term. So it'll be the sum of nck's x to the, it's not n plus 1, it'll be x to the, see how it's x squared, x cubed? Look how we've got nc1, x squared, nc2, x cubed. Notice the x power is 1 higher than that. So it's nck, x to the what? K plus 1. X to the k plus 1 over the k plus 1. Because look, nc1, x squared on 2. So it'll be nc2, x cubed on 3. nc, whatever k is, x to 1 power of k higher over the same number. Now, what's it starting from, Bob? Yes, it's starting from k is 0 through to k is, see we're starting with the 0 because it's nc0 x to the 0 plus 1 gives us x to the 1 on 1. Alright, and what does it go up to? K is what? Yeah. So notice when we integrate this, we stay the same. The k is 0 to the n. Whereas when we differentiated it, we went from k is 1 to n. That's why I'm saying you need to expand it. Otherwise, if you get one of these wrong, you'll lose a mark. Okay? So that's the first part where we've integrated both sides. Part 2, now we do our substitution. By substituting x is 0, substitute x is 0 to find k. So whenever you do this integration type and you get your plus k or your plus c, your next step is to work out what that k or c is. And the best thing to do is to substitute x is 0 because it wipes out the whole of the right-hand side. You can do it in the expanded version if you like, or the condensed version. I'm going to do the expanded version. So I've got 1 over n plus 1 times 1 plus x to the n, 1 plus what? 1 plus 0 to the n plus 1 plus k equals, I'm going to do it in the expanded version. I'm going to substitute x is 0 in the expanded version, and what would I get? 0, wouldn't I? If you substitute x is 0 in the first one, you get 0 plus all these zeros, etc. So I've expanded it into the, I've substituted into the expanded version instead of substituting into here. Okay, x is 0, 0, 0. You're just getting all zeros. Therefore, k is what? Isn't it 1 on n plus 1? So don't I have, what's 1 to the n plus 1 going to be? So 1 over n plus 1 times 1 plus k is 0. Because n is a positive number. So 1 to a positive power is just 1, so therefore k is negative 1 over n plus 1. So part 3. Now, of course, that k is negative 1 over n plus 1 should go into this expression or that top one. We'll do that in part 3. It says part 3, substitute x is negative 1 to show that So we're substituting x is -1 to show that the sum from k to 0 to n of -1 to the k, nck over k plus 1 equals 1 over n plus 1. So substituting x is 1 into the original expression. Now, and putting in that value of k that we know. So let's put the value of k that we know. So we've got 1 over n plus 1. I'm not going to substitute the x is 1 yet. Times 1 plus x to the n plus 1 plus k is minus 1 over n plus 1 is equal to the sum from k to 0 to n of nck x to the k plus 1 over k plus 1. So what I've done, I've written out this result up here, the integrated result, and because we worked out what k was, I've substituted it back in first. I haven't substituted my x is 1 yet. So I'm just putting what my k is. Whoopsie. Wait a sec. So all I've done is substituted that k value up in here, in my result, my integration result, okay? Because that makes sense. That's what we always do when we work out the constant. We put it back in. Now I'm going to substitute x is -1. Look, I'll see whether I can probably just substitute straight in. Let me just see if I can. Okay? I might be able to just put the k is -1 here. Not the k is -1, the x is -1 there. Let's see. So I get 1 over n plus 1 times what? 1 minus 1 to the n plus 1 minus 1 over n plus 1 equals sum. I'm going to substitute into the condensed format, into the summation format. Don't I just put a -1 to the k plus 1 here over k plus 1? Do you see what I've done? So I haven't done it into the expanded version. I'm going to see, because I'm looking at this result, I'm thinking I should be able to just do it in here. But look what I'm trying to get. I've got the sum from k is 0 to n of -1 to the k. Here I've got -1 to the k plus 1, so I'm going to have to do something with that. So what am I going to do, girls? What have I got here? Do you see what I've just done? I've just substituted k is 1 there and k is 1 there. So what is this? 1 over n plus 1 times what? 0. So I lose that. So I get 0 minus 1 over n plus 1 equals the sum from k is 0 to n of nck. Now guys, I don't want in my solution -1 to the k plus 1. I want -1 to the k. So what do I do with that -1 to the k plus 1? No, I can write it as -1 to the k times -1 to the... Haven't the indices been added? -1 to the k times -1 to the... What will I put up here? 1 over k plus 1. We're nearly there, girls. So -1 over n plus 1. See this -1 to the 1? Why don't I just pull it out the front and say that equals negative of all of this, nck, -1 to the k over k plus 1. Do you see what I've done? If each of these terms is multiplied by -1, I may as plus the next one times by a negative and the next one's times by a negative. I'm just going to pull the negative up to the front. Does that... Because whatever you're going to get here, you're going to times it by -1. And whatever you're going to get here when k is... So you're going to get a k is 0 term, you're going to times it by -1. You're going to get the k is 1 term, you're going to times it by -1. You're going to get the k is 2 term, you're going to times it by -1. Why don't I just put a negative in front of each term, pull out that negative to the front, and put it out the front of each term? I've moved that -1 to the front. Instead of each term being multiplied by a negative and then adding them all together, it's the same as taking out negatives, a common factor for each term. So I've pulled out the -1 to the front. So I've pulled out the -1 to the front. So now, girls, I'm nearly at the result. Look at what we're trying to prove. look at your sheet. All I've got to do is swap sides. If you just put whatever's on the right to the left and whatever's on the left to the right, you've got the result. So at the moment I've got negative of that. Do you want, so all I do is, so therefore, n, so that taking it over to the other side equals this one taken over to the other side. The way it's written out here to show that up there, that result there, that's just sum from k is 0 to n. You can put the nck over that. See, nck times negative 1 to the power of k. I can bring the negative 1 to the power of k to the front times nck over k plus 1. These two, the nck and the negative 1 to the k are on the numerator and k plus 1's on the denominator. They're multiplied by each other. Equals 1 over n plus 1. Do you get that? Yeah, because it's just that times that over that. So I can write either the nck on its own or the negative 1 to the k on its own. Okay, this is question 3. Now it does say this question follows the same steps as question 2, but I don't want to go back and look at those steps. I want you to be able to start deciding what you're going to do in each of these questions. So for question 3 it says consider 1 plus x to the power of 2n is equal to the sum of all terms from r is 0 to 2n of 2n cr x to the r. Normally we've got an r in place here where there's normally a k. No big deal. The first part says show that the sum, basically it's the same as that, the sum from 2n, from r is 0 to 2n of 2n cr equals 2 to the power of 2n. So we're trying to show this result given this thing up here. How do you think, look at the right hand side here, how do you think they got 2 to the power of 2n by substituting what? How do you think, yeah, x is 1. How are you going to get that result? If you substitute x is 1 here, you're going to get 2 to the 2n, and look at the right, if you substitute x is 1, 1 to the power of some positive number is 1. So all you'll do is, you'll take the first bit, 1 plus x to the 2n, start with that, equals sum from r is 0 to 2n of 2n cr x to the r. Then you write, substitute x equals 1. Then you will get 1 plus 1 to the 2n equals sum of all terms from r is 0 to 2n of 2n cr 1 to the r. Alright, so I've just started with what they've given me. See, that's the question. Started with what they've given me, so given that, I'm substituting x is 1, it gives me that. If it says show, you need to show all steps. So therefore 2 to the 2n equals sum from r is 0 to 2n of 2n cr, because we know that as 1 to the r is always equal to 1, because r is a positive integer, as r is a positive integer. So 1 to the power of r is always 1. So that's part A. I'm just going to write out what part B is. Part B says show that 2nc1 plus 2nc3 plus 2nc5 plus 2nc to the 2n minus 1 equals 2 to the power of 2n minus 1. We'll just pause. Okay, so